In example 3, we're going to look at what happens to our set notation if the number lines show discrete data. In other words, the points are not connected, so we have a set of integers only. What happens to the set notation? So if these were our domains, refresh if you need to what all these symbols mean. There's a page in your notes that you can go back. The order is important and you have to remember the order. So we're going to start with our curly brackets, and because we're talking about domain, I'll just default to x. So the set of x such that we have a definite beginning place, our lower bound is at -2, and a definite end point, our upper bound is the number 3. If we're looking at how to write our set notation, remember, if you put your lower value on the left and your higher value on the right, all of your x values will be in between, so you write your x in between your 2 and 3. Your lowers on the left, your highers on the right, you'll use less than symbols. So -2 will be smaller than all the x's in this list, and all of the numbers in this list will be smaller than 3. So we have to decide now about these endpoints. There is a dot at -2, so I would write equals, it's included. There is a dot at 3, so I would write 3 is included and write that equal sign. The difference in between our notation now is going to happen here when we look at what number system. So remember, real numbers are continuous and we would have number lines drawn here. These are not continuous data graphs. So I look at the numbers, and since there are negative values, all of these numbers, -2, -1, 0, 1, 2, and 3, all belong to integers. So this is my complete set notation for part A. For part B, we'll still have the set of x such that starts. It'll always be x belongs to some number system. And because I have a definite start point here at -3, all of the numbers will be less than that, and all of the numbers will be greater than that -3, and all the numbers in my list will be smaller than 3. -3 is the lower bound, and it's dotted, so it's included. 3 is the upper highest number, it's included, so I can write my equal sign. So -3 is less than or equal to all the numbers in the list. All the numbers in the list are less than or equal to 3, and all of the numbers in the list belong to integers. I just want to take a second to show you that there are other ways that are also correct to write this. So I would still have to say they're all integer values. All of the numbers here in my list, but I could use the -4, and I could use a +4. Lower, lower. So here I'm saying all of the numbers are going to be integers. -4 is smaller than any integer, but not equal to. So -4 is the smallest integer, but don't include the -4. 4 is the largest integer, but don't include the number 4. So this is really, what are all the integers between -4 and 4, but don't include those two numbers. So -3, -2, -1, 0, 1, 2, 3 are all the integers between but not including -4 and 4. Or I'll show you one more way. I could still say x such that -3 we know is included, 4 is not, and they're still integers. So here I'm saying the set of x such that all of the x's are greater than or equal to -3, and all of the x's, the numbers, are less than 4, but not including 4. So those are all ways you can still write discrete data. There's not just one correct way. All right, so take a bit of time to review when you use solid dots, when you use open dots, and what that means for the different set notations you will see in your work samples.